Good morning. Uh, Thank you, everyone, for joining this webinar, the first webinar in the Finley Chair webinar series. So we used to have these seminars actually as a face-to-face seminar before COVID. And because of the COVID, I think we moved it to a more of a webinar series. And so today we are actually talking about the enhancing social media analysis with visual data analytics. So just a little bit talk about introduction. So I'm Hemant Jain. I'm the Max Finley Chair in the College of Business, Rollins College of Business at the University of Tennessee, Chattanooga. And we'd like to first thank Finley family for making this possible. They sponsored the Finley Chair, which I hold here. And as a part of the chair's activity, we organize the webinar series. And in this series, we try to bring in the world famous, well-known researchers from all over the world to present the latest in research in the area of information systems, AI, analytics, all related technology related fields. And so it's really an exciting series. We also do a set of focused seminars on specific technologies, and these are longer, half a day seminar. We will be starting those soon. So again, without any delay, let me introduce our speaker today. Our speaker today is Dr. Jean-Mo Lee. Dr. Lee is the Associate Professor of Information Systems at Sauder School of Business at the University of British Columbia, Canada. So he's coming to us from Canada. He received his PhD in computer science from University of Texas, Austin in 2015. And his research primarily focuses on the advanced business analytics using AI approaches. So he kind of combines the best of the AI into the business analytics. Even though he's coming with a PhD in computer science, he has a lot of business experience. He has published papers in all the top information system journals like MIS Quarterly, Information System Research, Journal of MIS, Journal of Business Ethics, and then also on the ACM journals and the IEEE conferences and the journals. He has received 17 grants to support his research from National Science Foundation in the US and the Canadian agencies and many industries. Dr. Lee combines an experience with the industry and the academic too. He worked with Samsung Electronics, AT&T, Intel, and Goldman Sachs. So he has a wide experience in a variety of industries. And he collaborates with tech firms like Yahoo, IGA Works, Christie, Canada Energy, and so on and so forth. And he holds 11 patents to himself. So I'm extremely happy to welcome Dr. Lee to this seminar series. Few housekeeping things, which we generally do when we have a face-to-face seminar. And so for this seminar, couple of things, Dr. Lee wants it to be an interactive. So feel free to stop and ask questions anytime. You can just unmute yourself and ask questions. Also, I'll request as many of you as possible to keep your video cameras on. I think that gives you a good interactivity. And without any delay, I will hand over the things to Dr. Lee. Dr. Lee.
Thank you very much, Dr. Jain, for the kind introduction. And thank you for having me today in this seminar series. I'm very honored to be here today with you. Let me start sharing my screen so we can get started. So can you see the screen okay? Is it? Yeah, thank you. Okay, all right, okay, thank you for turning on your videos. I can see your beautiful faces. It's all wonderful. Even though it's not in person, having this like face-to-face interaction helps me a lot. So today I'm going to talk about one of my research on social media analysis using video and visual analytics using a machine learning approach. So again, my name is Gene. You can call me Gene, and I'm from Sauder School. So this is my campus in UBC. Someday I wish I can have you in Vancouver. It's a beautiful city, not in winter, but in the summer it's wonderful. Okay, so before I jump into the actual talk, I want to give you an overview of my research area on AI and analytics. So as Dr. Jain introduced, so I do research on business analytics using AI approaches. So when we say big data, people talk about 5 V's: volume, velocity, variety, veracity, and value. So in my research, I mainly focused on the variety side and the value side. So if you think about the data set we are dealing with these days in business and society, many of them are in the what's called unstructured data format. So traditional approaches mostly work for numeric data set, but now we see in the social media, we have videos and YouTube videos and Instagram photos, and you have podcasts listening to to conversation. So all of these data sets are in unstructured format. So based on the industry reports, about 80 to 90% of the data we generate these days are in the unstructured format. So the question is, how do we analyze them to make sense? So in my research, I use a lot of AI technologies, such as machine learning, natural language processing, and computer vision to analyze these unstructured data. So that's my research theme. Within that research theme, I have 3 streams in there. So one is to understand online platforms, how people interact in the online platforms in this with this unstructured data, such as mobile app market or online review platform or online labor market. Also recently working on online dating market. So another research stream is to actually develop new methodologies for these to understand this phenomena. So for this one, I draw on a lot of advanced AI technologies. The third stream is on the unintended consequence. So if you have a lot of analytics AI, maybe you've heard from the public media that there could be a lot of biases or any like misinformation issue in social media. So one of my research is on how do we address those unintended consequences, such as cybersecurity, misinformation, and privacy, and more. Again, so I wanted this to be very interactive. So in case you have any questions, just feel free to unmute yourself or raise your hand so we can have a more interactive conversation. So this is my the website of my so if you want to know more about, feel free to visit here. I want to give you a brief introduction by 2 of my papers, and then jump into today's paper. So this one was published in MIS Quarterly 2016 to understand startup industries. So if you think about tech startups, those are like they're trying to create new values and new business models. So traditional business classification, industry classification doesn't really work in the startup industry. So in this paper, what we've done is to use LDA topic modeling. It's a text mining tool to understand the business of tech startups. And then using that new measure to understand the startup M&A transactions. So these are the transactions common that we use in our data. And then you can see that using NLP technique, we can understand the unstructured text data pretty well. Another paper I want to introduce was published in ISR 2020. It's on mobile app market. So if you use mobile app, I guess you are using, sometimes you may see some apps are promoting some other apps. So this is called cross promotion. So we work with a company that is the matchmaker of this mobile app market. So the question is, how can we match those different apps together that will maximize their performance? So this project was to understand mobile app market using, again, LDA topic modeling. And then we can actually quite accurately predict the app downloads, and after you download, how long you're going to use it. And then we devise a matching algorithm to improve this matching efficiency. So that's the second paper. And then the one I'm going to talk about today is on the social media image analytics. So you can see the theme here, right? So first paper I introduced was on the text analytics, and the second one was on the mobile app analytics, and now it's on the image analytics. So you can see the data type is changing. So actually the current paper I'm working on these days, it's on the video analytics and audio analytics. But the one I'm going to present today is on the social media image analysis. So this paper was actually a collaboration with Yahoo Research. So this is a okay. All right, so let's get started with the paper. So this is a joint work with Dr. Dong-hyuk Shin, Shuhei, and Andy Winston, and then from researcher from Yahoo and Alibaba. You can see that all our co-authors are in different affiliations now, but when we started, 3 co-authors were in the UT Austin, 4 co-authors were in the UT Austin, and then 2 in Yahoo. And over the years, we all emerged at different places, and now we are. So it's a joint work with many different people, and it's been published in MIS Quarterly last year as a research method article. So to give you some background, so I mean, we all use social media, I guess. I'm using LinkedIn to manage my social, like professional network, Facebook to share my photos with my family, etc. So it's growing rapidly. And because of that, a lot of marketers are using social media to promote their products. So as you can see in these 2 graphs, so it's growing. So the internet ad is increasing dramatically. Within the internet, so search ad is still number 1, but social display ad is number 2 these days. So a lot of companies are investing on the social media advertising. But there's a challenge. So which is, as I mentioned, it's unstructured nature of the data. So if you do a very good job in text mining, then you can cover about 14% of social media posts, okay? But if you want to really get the majority, 78% of the social media data includes photos, okay? So you can imagine, like, you need to really understand this photo to do a social media analysis. I think the motivation one, I think, is pretty clear, right? So the research questions are, so how can a firm optimize their social media strategy by incorporating this visual content, okay? And then more operational wise, how can we measure this unstructured data source, the visual data and the textual data? So actually those textual and visual medium, they have quite a different role. If you think about textual data, you need to read with a lot of conscious effort, but visual data, you can just skim through very quickly. So depending on this medium, you have a very different consumer behavior. And how do we understand that? So thinking about the literature in the MIS field and marketing and other computer science fields, so many of the existing works actually just mainly focus on textual data and the network structure and the audience size, etc. So, so quite limited work on the social media visual content. Now, actually, more and more people, researchers in the IS and marketing and finance and also accounting, now more and more researchers are trying to incorporate this image data into their analysis. So this paper is really to give a research framework, a methodological framework they can use for this image data. Okay. Any questions so far? Is it well motivated? Okay, thank you. So I can see from your visual cue, your facial recognition. I did my image analysis using my brain, so it's going well. Thank you. Okay, so so it's an unstructured data. It's a new territory. So we need to think about, like, how can we analyze these new data sets? You can think about a lot of machine learning and data mining approaches, but before we get in there, we want to have a very strong theoretical framing to tackle this problem. So we rely on this, this theory called elaboration likelihood model, so ELM, persuasion. It was introduced by psychology researchers some years ago. So the idea is, so when you try to, when you have an information in front of you, so you may have a very good motivation to use your cognitive effort to process the data. Or if you're not super motivated, you may not really pay attention. You will use a very superficial information to process that content. So it's been this, so elaboration is the motivation. Based on the elaboration efforts, you may use 2 different routes to process the information. One is the peripheral route, the other one is the central route. So you can imagine, so if you for the content that you are not really motivated to process, you may use a peripheral route to use simple cues, heuristics, or familiarity. So you're not going to use that much of an effort. Okay, so otherwise, if you are very motivated, then you will use your central route to use high level of elaboration. You try to really grasp the message of the content, then that will require more cognitive efforts. This theory is actually quite related to the Daniel Kahneman's behavioral economics theory on system 1 and system 2. So it's a question. Dharmarajan?
Yes, hi. I wanted to ask regarding the peripheral route versus central route of processing the data. Where you recommend using those? I mean, I think that's spot on that you use the simplistic cues in the first pass, and then you go to the central route when you want to elaborate. But how do you recommend structuring data? What kind would you do? Your papers go into the details of the algorithms or the types of algorithms that are that you classify as peripheral versus central?
Thank you for your question. That's a great question. Yes, in our paper, we rely on 2 different routes, and then within those routes, we try to use machine learning to quantify the simple cues and the attractiveness using machine learning, and also for the elaboration, like how the textual is complex or image is semantically complex. I'm going to talk about that in the next slide, but and also we use the followership information. So if you're a follower of a certain content, you will have motivation to use your central route, versus if you're new to this content, then probably you'll be more using the peripheral route. So in their analysis, we do incorporate those motivation. Yeah, thank you.
The reason I was asking the motivation and the fact that you use follower data also makes me wonder about how this would work for something that's new and doesn't have followership yet.
So that's a good question. So in those cases, so maybe I will forward to the data side. So actually we use social media content from established companies. So in that sense, those contents are pretty well known already to the consumers. But your question is very good, that for the new data, new kinds of information, I would argue the peripheral route will play a more significant role. But we haven't tested it in this paper.
Understood. Thank you.
Thank you. Okay, so within the ELM, what I want to mention again, another one is that it's not really of the type of information you process. Even with the image data, some of the image features can be more related to the peripheral route versus central route. It's how you process the information. And we argue that visual and textual content can play a role in both routes, depending on the specific characteristics of the text and image. So, so what we did on this paper, we actually dig into the literature on cognitive science, psychology, advertising, information systems, and a lot of different fields to really understand what kind of visual contents we have already understood. Okay, so this is the table we came up with. So on the top portion, we argue those are more related to peripheral routes, such as celebrity endorsement, sexual appeals, aesthetic level, and visual complexity. This one is more, visual complexity is more pixel level, the flashiness of the image. So we argue that those are related to peripheral, but bottom ones are more central routes. So such as design complexity, how structured your image is. Also, how image and textual data are similar to each other. So that one, you need to have some cognitive efforts. Or content consistency. So if you have already, so how similar the focal content is related to the previous content in the same channel. So that one we argue are in the central route. And then the third column gives you all the papers that has analyzed these different aspects. So one thing I want to say here is that those studies are usually in the lab experiment format or surveys based on small samples. And the data they analyzed was usually manually coded by researchers. So in that sense, there's a scalability issue, like generalizability issue. And the other question is how all those different features will play together. It's still an open question. Okay, so let me now introduce our data set. So as I mentioned, we collaborated with Yahoo Research. So they have, when we started this project, they recently acquired Tumblr, a microblogging platform. So you may know Tumblr. It's similar to Twitter in some sense, but it's more free format. So Tumblr is our focal data set. So within Tumblr, the data set is some years ago, back in 2014, there were 180 brands using Tumblr to do social media marketing. So these brands include automobile, entertainment, and a lot of different sectors. They have generated about 34,000 posts. These are brand generated posts. And then that includes many photos, 53,000 photos. And then within this data set, we analyzed it. And so we found that 88% of the data of the post have photos and text together. And then 7% text only. So back in the day, only 4% were videos. But now you can imagine if I replicate this study now, then more and more data will be in the video side. But back in the day, it was still images, not videos, mostly. To understand the consumer engagements, we collected the likes and reblogs. So until April 2015. So after many months after they posted the, okay. So these are some example posts. So BMW, and then Vogue, Fashion Magazine, and the third one is IBM. So different sectors are using different kinds of image to promote their content or promote their new product or events, etc. And this is an example sample post. So this was a fashion brand that came up with a new product. And so they have the image to show the product with a model. And then under the hood, underneath they have some text data, the tags, and the description of the new product. Okay, so that's the post we're interested in. The right-hand side is the reaction from the consumers, how many likes and reblogs. So they call it user notes. So in this paper, our main contribution is to use deep learning to understand social media analysis. So I'll walk you through with an example. So let's say this is a target post. So I think it's like some dishes, like some recipe description maybe. And then from the image, we can get object level complexity. So semantically, what kinds of objects are in there? Is it beautiful aesthetically? Or is it an adult content? Or does it have a celebrity inside the photo? So these are the features we get from the image. From the textual data, we can see, oh, is it topic-wise, is it complex? Or is it, in the sentence level, is it complex? So reading complexity or readability score, if you will. Across the image and text, we can also measure their similarity within the post. So are they telling the same story consistently, or are they complementing to each other? We also analyze the consistency by using the previous post and then compare the image and text-wise consistency. So complexity, similarity, and consistency. Those are the three main features. Okay, so in terms of the remaining in the flow, I will introduce how we construct those features, and then how do we validate it, and then we have two case studies to show their effectiveness. So case study one is to use it in the social media popularity prediction. So basically, if you're given a post without any user reaction, can you predict how popular this post will be based on the image and the text? The second study is on more of an econometric study to use these ELM framework to understand what kind of image and visual features will impact the ad effectiveness. Okay, So any questions so far? Facial recognition check. Okay, good. Thank you. Thank you for the smiles. All right. So the first one is the pixel level complexity. So visual complexity theory from cognitive science, it argues that if the image is flashy, like the neon sign like you see if you go to Broadway in New York, like you will see a lot of flashy images. Those colors, luminous texture will create more attention. So that's a theory. And how do we capture that? So it's a very simple measure. So if you can compress the image, that means it's a very simple image. Okay, so we capture the pixel level complexity by using the compression ratio. So, however, the issue, as you can imagine, the issue is that it only captures low level, pixel level complexity. It doesn't really understand the semantics. What kind of high level semantics does the image convey? So this is where we have the deep learning algorithm. So deep learning algorithm has been used in many different applications. One of the computer vision to recognize images, the objects in the image. Let me give a very brief introduction of what it is. So this example is one of the deep learning algorithm called convolutional neural network, CNN. It has been widely used in the image recognition tasks in different firms. So if you use Google search, Google image search, they are using CNN under the hood. If you use Facebook and Facebook facial recognition, part of it is using CNN model too. So how it works is if you think about image, it's in the mathematical form, it's just a two-dimensional numbers. It's just a matrix where each element is an RGB value. Okay, so it's a two-dimensional matrix. And then you convert those matrix in different layers using this what's called convolutional layers and fully connected layers. So as you transform this image as you go, it's called deep network because it has many layers of this transformation. And then at the end, you can make a prediction. What kind of prediction? Do I have cat in this image, dog, or boat? So we can actually we can identify about 1,700 objects. So we train our data using 1.5 million images. So now there are many Google Clouds and Microsoft Azure and Amazon recognition services. They all provide this image recognition. So if we do the study now, we can just rely on those cloud services. But back in the day, we started this project some years ago. We didn't really have that clear cloud services. So we actually built our own model using ImageNet data and Flickr. So Flickr is a photo service by Yahoo using their label data. So when we train this model, using this 1.5 million images, what we get is for each image, we can transform it into the 1,700 dimensional vector. So each of the dimension corresponding to a label. So for example, in this case, this photo has there's a 94% chance there's a boat inside. Okay. So this is our training data, one of our training data set, ImageNet. So ImageNet has been introduced by Stanford Computer Vision Lab. So they have actually manually labeled all these images. So it has this semantic structure. So in this, there's a category of person, inside there's an expert, and inside there's an analyst, and these are some example photos of analysts. And we use for the training data set. Okay. So once we have the CNN model trained, you can transform each image into a 1,000-dimensional vector. And then we try to compute the semantic complexity. So a very simple idea, if you have many different kinds of objects in your image, we argue it's semantically complex. If there's only one object inside, it must be simple. So how do we quantify that? We use entropy, Shannon diversity index, a very well-known entropy measure on those vector, 1,700 dimensional vector. Okay. So that's the, so we have the visual complexity in terms of the pixel level and the object level. Using the CNN model, we can do more things. So in the machine learning, there's something called transfer learning. So once you have a trained data set, trained model, you can apply it to different related tests. So for example, using the CNN, we can also measure how beautiful this image is, aesthetic score. We also know if it has an adult content inside, or we can also recognize celebrities, 450 celebrities inside. So using this transfer learning. Okay, so let me give you some examples here. So the top left image has a low pixel complexity because it's black and white-ish, it's not flashy. There's only one type of object, bag, right? So it's semantically, it's also simple. Right below the quadrant one, it's flashy, right? So it's pixel level complexity high, also object complexity high. Okay, so you can see some examples like that. Okay, so that was the image features. So now textual features too. So text mining has been quite widely used in many literatures. So we argue, so this theory of text comprehension argues about two different levels, micro level and macro level. When you read, so think about when you read a text, or a news article or a journal article. So you may think about the whole picture, the topic, right? The whole meaning of the entire text. So we capture that using LDA topic modeling. So if this article is talking about many different topics, we say it's topic level wise, it's complex. Another level is that as you read the text in the micro level, maybe the sentence flows pretty well. You can predict what's going to come next. So we call it micro level of complexity, and we use word-to-vec embedding. It's another deep learning model for text data to measure the sentence level complexity. So can you recognize the word by word easily? Okay, so these are some examples. So the two texts in our data set. So the first one is topic-wise, very simple because I only talk about one thing. And then also sentence-wise it's simple. But the second one, it's talking about two different topics. And sentence structure-wise, it's not really easy to read. I'm not going to ask you to read the actual one, but so you can see the numbers next to it. Okay, so now we have the text data and the visual data. The third one is how we analyze text and visual together. So pixel data, as I mentioned, is a two-dimensional numbers, right? It's a matrix. The text data it's in character, alphanumeric characters. So they don't really have a common representation. So it's not easy, it's not straightforward to measure the similarity between those two data sets, right? Data types. So our idea to tackle this problem is, so from the CNN model, we can recognize the labels inside the image. Okay, so those labels are now textual data, right? So we can use that label data as the corpus of the image, if we call it image corpus. And then we have the text corpus itself. And then we run LDA on both data together. Okay, and then we can get the topic level cosine similarity between the image labels and then the text, the words. Okay. Some examples here, 3 posts. So the first one, second column, the image itself and the text and tags are quite related to each other. So the last row says 76% they are similar. The last one on the right-hand side, the image and the tags are not so tightly related, so we recognize that 0 similarity. Okay, the last one is the consistency measure. So we use the image data and the textual data to predict the labels, topic distribution, to see if the image and the text is consistent to the previous post. Okay. So I gave you a lot of different features. So you may be wondering, oh, they're all good, they're using machine learning, that's cool. However, how do we know how can we validate them? So how do we make sure that those are those measure we construct are consistent with the theory that we're relying on. Okay, so what we did here is to use Mechanical Turk, Amazon Mechanical Turk, to actually show a pair of image or pair of text to the coders and ask them, hey, which one is more beautiful? Which one is more complex in object? Is the image text similar? Which one is more similar? So we ask those questions to Amazon Mechanical Turkers and then see if what they're saying is matching with the machine learning generated values, okay? So the table shows you the match percentage. So we can see that the object complexity, 92%, pretty good match. Aesthetic core is okay. Image text similarity is 81% matching. I would argue it's not perfect, but it's good enough to move forward in our study. And you can also say that image text similarity, even for the human cognition, people have different standards when they analyze these. So I would argue that there are many more future research we can do on this. Like there are a lot of theories on human image processing or information processing in general, a lot of theories in that. And then we have on the other side, the machine learning models so if we tie them together tightly, I think this will be a very important contribution of our field. So this one is a very crowded table, but basically the top portion is the dependent variable, the likes and follow, the reblog counts. And then we have the visual features and the visual textual together, and others such as number of followers. So these are our data sets of the study. Okay, so now we constructed those features. Now we want to see, do they really help in our, to advance our theory? That's the question. So we have two case studies. I will first introduce the predictive study on social media popularity. Okay, so